grade teachers. Today we are going to take a look at Unit 8, Two-Dimensional Shapes. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. Chapter 1, AKS and IOAs. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit A. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's take a look at the AKS and IOAs for Unit 8, Two-Dimensional Shapes. Just as a reminder, at the end of each AKS and each IOA, in parentheses, you will see the state coding that you can use as a reference if you are searching the Georgia DOE website for resources. Unit 8 is our geometry unit. Students will learn how to identify perpendicular and parallel line segments, along with right angles and polygons. They will classify as well as compare and contrast polygons with a focus on quadrilaterals. They will also learn about three-dimensional shapes as well as symmetry. Let's take a look at each IOA that we will be teaching in this unit. IOA 6A is where students learn how to identify perpendicular line segments, parallel line segments, and right angles. They identify these in polygons and solve problems using these geometric terms as well. IOA 6B. Here, students will classify, compare, and contrast polygons based on properties. However, there is a focus of classifying and comparing and contrasting these polygons with the focus being on quadrilaterals. Those quadrilaterals include squares, rectangles, rhombi, parallelograms, trapezoids, and kites. Another part of this IOA, or learning target within this IOA, is where students analyze specific three-dimensional figures. They do this by identifying and describing quadrilaterals as faces of these figures. And the last IOA, 6C, is anchored in symmetry. This IOA requires students to identify lines of symmetry in polygons. Finally, you will see this AKS has one extension. The new extension IOAs are there to support the differentiated needs for your students. As you can see, the word extension is bolded and in parentheses at the end of the IOA to denote that they are just that, extensions, and they are specific to Gwinnett County. Please remember, you will not find resources from the state of Georgia for these IOAs, nor will they be found on the pacing guide. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's head over to eCom to see how the pacing looks for these AKS and IOAs. On our Quarter 4 pacing guide, we will review Unit 8. Here we are at the start of Unit 8, on our pacing guide. In this portion of the pacing guide, you will see the name of the unit, which is Unit 8, two-dimensional shapes, a suggested pacing, which is about 2.5 weeks, and this unit will focus on the big idea of geometric and spatial reasoning. In the box below that, you will find the AKS and IOAs we discussed in Chapter 2. The AKS is here, and the IOAs that support that AKS are here, that also include the extension IOA here. Don't forget the left column of the pacing guide lists the progression of an IOA through the concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as the manipulatives or tools that students will need for this day's particular lesson. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days you will see instructional resources linked for the numeracy components of a traditional teacher-led lesson. Other days you may notice a task-based lesson, which is your full numeracy block that day. You will also see resources from the Georgia DOE website, along with lessons from Georgia Reveal, which is our newly adopted resource. We begin Unit 8 with IOA 6A, and it has a suggested pacing of 3 days. We then move into IOA 6B, which has a suggested pacing of 5 days. These 5 days includes work with both two-dimensional shapes and three-dimensional figures. And then we finish up the unit with IOA 6C for 2 days. We kick this unit off with task-based structured inquiry lessons that are anchored in IOA 6A. The first lesson activates students' background knowledge about the types or categories of polygons and how these are defined. Then the following 2 days, we shift into learning about the specific attributes of two-dimensional shapes, specifically what are right angles, and identifying perpendicular line segments as well as parallel line segments. Learning about right angles is anchored in a task-based lesson, and the perpendicular and parallel line lesson is anchored in a structured inquiry lesson. We then shift into IOA 6B, where students make application of the attributes they've just learned about and using those attributes to classify and compare polygons. Students determine which polygons can be classified as having the same attribute. After exploring our two-dimensional shapes, the learning shifts towards focusing on quadrilaterals. Students will learn how to use attributes to specifically compare and classify quadrilaterals. After working with two-dimensional shapes, we shift into working with three-dimensional shapes. Students will work to identify and describe the quadrilateral faces of the three-dimensional figures. Our last IOA is 6C. This requires students to identify lines of symmetry and polygons. The manipulatives you will need throughout this unit are found in your math kit. Specifically for IOA 6C, your students will use the Geo-Mirrors, pattern blocks, as well as the geometric shapes they use when working with two-dimensional figures. Students will also work with Anglegs in identifying the attributes with 6A in two-dimensional shapes, and then when they begin working with three-dimensional shapes, they will work with the geosolids. All of these tools, the Anglegs, geometric shapes, geosolids, and Geo-Mirrors, can be found in your math kits. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to Analyzing the Standards for guidance on additional instructional strategies for each IOA. Let's take a look at some instructional strategies that will support our geometry unit. The first IOA we're going to look at is IOA 6A. Our kids are required to identify perpendicular line segments, parallel line segments, and right angles. They also have to identify these attributes in polygons as well as solve problems with them. Our thinking is going to be anchored in this problem today. Milo has to sort a set of shapes using what he knows about attributes. What are the different ways he can sort the set of shapes? Well, we are going to be sorting shapes based on these geometric attributes here: perpendicular line segments, parallel line segments, and right angles. We are also can build on what your kids will come to third grade with from second grade, knowing the number of sides, number of vertices, number of angles, side lengths being equal is something that they focused on in previous grade levels also. All right. The tools we will use for this include your Anglegs that are found in your math kit, as well as these geometric shapes you see under the screen here. And they come in a tub that look like this, so you know what you're looking for when you go into your math kit. All right, so before we can get into our problem, we have to know what these geometric attributes are and what they mean. So let's talk about the parallel line segments. Parallel line segments never intersect, and the line segments are always equal distance apart. I'm going to use my Anglegs here to model that, and you can see these line segments will not cross as they continue on the plane that they're in, and they remain in equal distance apart. All right. The other type of attribute our students are learning about is perpendicular line segments. Perpendicular line segments are opposite from, or just different from, parallel line segments. They actually do cross, and when two lines cross, they form a right angle. This right angle can be identified using a square if you have access to one, but you can see a square corner is formed here, which a square corner is a right angle. There is another square corner, right angle here and here. Okay, so oops, let me turn that so that actually is perpendicular. Okay, parallel perpendicular line segments using Anglegs. The other attribute our kids have to learn about and know about are the types of angles. The right angle is what all of our learning is anchored in this IOA. A right angle is an angle that forms a square corner at the vertex of where two sides meet here. And you can see this square corner. You can also check, makes a capital L, letter L, and check that as well. The other type of angle our students have to know about in relation to a right angle is an acute angle. An acute angle, its sides are closer together, okay, compared to that of a right angle, which forms a square corner here. When the sides are closer together, it forms an acute angle. And we also have an obtuse angle. And in relation to a right angle, if this is my right angle, the sides of an obtuse angle are further apart, and we can see that there. Okay, just so you know, the markings of your angles will be inside the polygon. They'll look like this to show where angles are, and to mark a right angle, we will draw a square corner. That's doing the best I can freehand, but those are the attributes we have to teach our children. Let me pull these back over here. And as you teach these to your children, you will also be creating your anchor chart for your classroom, an attribute anchor chart. The types of angles, which we just discussed. There's the right angle, the obtuse, and the acute. The kinds of sides, parallel, perpendicular, and all equal sides is something that your students will have background knowledge of, as well as a number of sides, angles, and vertices. Okay, so knowing now that we have learned about our attributes, we can actually think about sorting these shapes. I have just a couple of attributes here I'm going to pull over, and we're going to anchor our thinking in this attribute, no right angles, right? I'm going to slide these off to the side, and I am just going to draw, actually, I'm just going to leave it like that. And I'm going to think about if this shape has right angles or not. One thing that is helpful for your students is to use a sticky note or a piece of paper, the square corner of the piece of paper, to line up with the vertex and determine if the sides where they meet at the vertex, if these two sides form a square corner. And in this case, this one does. So it has a right angle, so it cannot belong with this. It cannot go in this sort here. I can also use a sticky note or an index card and identify the right angles as well. So this shape definitely has right angles, does not fit with this attribute. Let's check out the trapezoid. I'm going to use my angle checker here. Actually, I'm going to use a clear piece of paper so you can see. I'm going to place my square corner line it up with this vertex here and see the side here is a line, but I can see that the side here is under the paper, okay, which means in relation to a square corner, these two sides are closer together, which means that is an acute angle, all right? I can turn it to measure the other angle in the polygon or check the other angle to see if it's a right angle or not. I'm going to line it up with the vertex. I see that this side on the bottom is lined up with the bottom of my square corner, but this side here extends beyond my square corner. So that means it's an obtuse angle. So this shape has no right angles. It can stay there. The one shape I do want to point out to you is this triangle. If we look at this triangle, most often students will think, oh, there are no right angles in there just looking at it. It is important and vital that your students rotate the shapes so that they check all of the angles. And I'm going to show you what this means like we did here. But here I'm going to line up my vertice with my square corner. And I can see this side aligns, but this side is under my paper, which means the sides the spread of the sides are closer together. But if I rotate it, and that means it's an acute angle, but if I rotate it here, I'm going to place my square corner here. Oh, wow. And I can see that this forms this particular angle in this triangle is a right angle. So this shape cannot be placed under this sort with no right angles. So that means it's an obtuse angle. So this shape has no right angles. It can stay there. The one shape I do want to point out to you is this triangle. If we look at this triangle, most often students will think, oh, there are no right angles in there just looking at it. It is important and vital that your students rotate the shapes so that they check all of the angles. And I'm going to show you what this means like we did here. But here I'm going to line up my vertice with my square corner. And I can see this side aligns, but this side is under my paper, which means the sides the spread of the sides are closer together. But if I rotate it, and that means it's an acute angle, but if I rotate it here, I'm going to place my square corner here. Oh, wow. And I can see that this forms this particular angle in this triangle is a right angle. So this shape cannot be placed under this sort with no right angles. And I would continue working with your kids in identifying whether or not shapes have right angles or not by checking all of the angles in the shape. And this one does not have a right angle, so it can be sorted there. And then you would continue with different attributes for your kids. Two pairs of equal sides. If we start looking at these shapes again, there's a pair of equal sides, there's a pair of equal sides. that fits. When I look at the trapezoid, these side lengths are equal, but these side lengths are not. So this only has one pair, so that does not fit. The triangle, these lines will intersect. They don't really have an opposite side. They have adjacent sides that intersect or that meet at the vertex, but there's not two pairs of equal sides. This pair of sides, they are adjacent to each other, okay? You can keep looking at the hexagon. There's a pair of equal sides, another pair of equal sides, and another pair of equal sides. So this one has actually more than two pairs of equal sides. If this had said at least two pairs of sides, this would have fit there. But then you can see we can continue to keep sorting. And as your kids gain access to identifying these attributes, go ahead and let them identify two attributes using the same group of shapes, and you will use a Venn diagram to do that, okay? But the important thing here is to know what these attributes are and what they mean. You can learn more about this in our Analyzing the Standards document. Please feel free to go check it out. Let's take a look at IOA 6B. That is one of the IOAs in our geometry unit, which is Unit 8. With this IOA, our students are required to classify, compare, and contrast polygons, okay, based on their properties. Those are the attributes we learned about in 6A. Going back up to the first line in the IOA, there is a focus on quadrilaterals here as well. Not just polygons, but quadrilaterals has a specific focus. Squares, rectangles, rhombus, parallelograms, and trapezoids, along with kites, are included in those quadrilaterals, okay? There is another part to this IOA, and it deals with three-dimensional figures. Our students have to analyze specific three-dimensional figures that include rectangular prisms and a cube, and they have to be able to identify and describe the quadrilaterals as faces of these figures, all right? So I've broken this up into two problems, two-dimensional figures and three-dimensional figures. We're going to talk about the two-dimensional figures anchored in this problem first, all right? The question is, which statements are true about all squares and all rectangles? A, they all have right angles. B, they all have four sides of equal lengths. C, they all have opposite sides that are parallel. And D, they all have four sides and four angles. So there are more than one true statement here. And as we know, our students will become very overwhelmed with seeing all of these words here, and that's a heavy lift in academic language. So they're going to have to continue to have experiences in working with polygons, specifically quadrilaterals, and identifying them identifying the attributes of these polygons. Remember back in IOA 6A, we identified the attributes for polygons students would be responsible for, specifically the types of sides, parallel line segments, perpendicular line segments. Are all sides equal? That's something they need to consider. The different types of angles, specifically a right angle and an obtuse angle as it relates to a right angle, and an acute angle as it relates to a right angle, along with their background knowledge of number of sides, number of angles, and number of vertices from second grade. This is going to be a tremendous piece. In order for our kids to gain access to this, they are going to have to put their hands on some shapes and really start thinking through how these shapes are classified based on their attributes, all right? To gain access to this, they can use their geometric shapes. They can also build their polygons, they're quadrilaterals with these Anglegs. Anglegs are fabulous for identifying opposite sides that are equal in length. There's another set. Are they parallel? Are they not? This will be very helpful for our students to build these types of shapes. Okay. But let's think through these geometric figures, again, found in your math kits, thinking about our attributes, right? Number of sides. Let's take a look at this triangle first. Okay. Here we see a triangle. It has 1, 2, 3 sides. We know it has 1, 2, 3 vertices, and the angles are located within the shape where the two rays meet to form the vertex. Okay. And that's where the angle is right there. All right. So there are 3 of those. Do I see any right angles in here? Remember, we can use an angle checker such as the square corner of a piece of paper. Well, if I look here, and I can place the shape on top of this, it's not really showing. I can see this is not a right angle because my square corner here is, and this side continues to get closer to the bottom side. These 2 sides push closer together, creating an acute angle. But let me rotate it and see. I'm going to rotate my triangle this way up. Look at that. This is a triangle that happens to have a right angle. So triangles can have right angles, okay? So I'm going to put here a check here and just put can have. Do they have parallel sides? Well, we can help identify that using our Anglegs too. We can place Anglegs on top and we could clearly see these 2 sides will intersect. Let's check over here. These 2 sides will intersect. There are no parallel sides here. Well, actually that is not true because we do have a right angle. Let's check to make sure. There are perpendicular sides. Yes, there are, because when 2 lines intersect and create a right angle, there is a perpendicular set of lines. So a triangle can have a set of perpendicular side lengths or sides. In this case, are all side lengths equal? Nope. These 2 sides are shorter than this side. And we don't have opposite sides. We actually have 3 sides that are adjacent to one another and that will intersect, right? So that's classifying the triangle, at least that one. This triangle does not have right angles, okay? This only has acute angles. And in this case, all sides are equal. So triangles can have all sides equal, okay? 2 different kinds of triangles there. Let's talk about our trapezoid real quick. Again, looking here, we know there are 4 sides, 4 vertices, 4 angles. Does it have any right angles? Again, we can use our square corner to determine that. Nope, it is not lined up here. I can rotate it and measure this angle. Nope, this side length goes beyond, is spread further apart than a right angle would be. Does not have right angles. So I also know that means it cannot have perpendicular sides. But let's see about parallel sides. If I were to place these Anglegs here, the opposite sides would eventually intersect. If I place the Anglegs here, these sides are opposite and they are parallel. If these lines were to continue in their same plane, they would never cross one another because they are equal distance apart. Oh, Anglegs a little bent or something's going on, but there is a 1 set of parallel sides, okay? Opposite sides are not equal in length, right? So your kids will go through and explore all polygons initially, and then they will jump into specifically looking at quadrilaterals. Move that out of the way. Let's take a look at our quadrilaterals. And the attributes are pretty specific here. You will see at the bottom of this checklist, and by the way, both of these checklists can be found in the Analyzing the Standards document as well as in our lessons. Quadrilateral, polygons with 4 sides and 4 angles. That's what we're dealing with here and with this particular attribute. It defines each quadrilateral. These definitions come from the Georgia DOE State Glossary. Right? So let's kind of start thinking through this per se. Again, let's take a look at our rectangle here. I intentionally built this with our Anglegs. When I look at a rectangle, Does it have at least one pair of parallel sides? And this side is parallel. These lines will never, they remain equidistant apart, and these sides are parallel. So yes, it has at least one pair. In fact, it has two pairs of parallel sides. It actually has two pairs of opposite sides that are equal in length. The Anglegs help us truly see this because each size, each color is a different size of the Anglegs. We can clearly see that this pair of opposite sides are equal and this pair of opposite sides are equal. So that is definitely true. Two pairs of equal side lengths of equal length sides that are adjacent to each other. Adjacent is defined down here as two sides that share a vertex, okay? So these two sides here, they are not of equal length. So they are adjacent, but they are not of equal length. Are all of our sides in a rectangle equal in length? No, they are not. Are there right angles here? Yes, they are. I can take my square corner and line it up and see my rectangle aligns with the square corner of my piece of paper. There is a right angle. I want to go back to the trapezoid real quick because this quadrilateral plays an important role in helping us classify them. A quadrilateral has at least one pair of parallel sides, as we noted earlier, okay? It has at least one pair of parallel sides. This term, at least, is how we define a trapezoid. That is considered the inclusive definition of a trapezoid, okay? At least one pair of parallel sides. Does not have two pairs of parallel sides. The two pairs of opposite sides are equal in length. Nope. We don't have any side lengths that are adjacent that are equal to each other. The side lengths are not equal, and there are no right angles in this. And again, we could go back and check with our angle checker if needed, but hopefully your students will, the more they work with the shapes, begin to see these attributes a little bit easier. Thinking about a parallelogram, this is an important quadrilateral. We have to be able to use and help us classify shapes. Does it have at least one pair of parallel sides? Yes, it does. Does it have two pairs of parallel sides? It sure does. Yes, it does. Are the opposite sides equal in length? Yes, they are. Are there two pairs of equal length sides that are adjacent to each other? So if these two sides, this side and this side, share this vertex, are they equal in length? Nope. This side is definitely longer than this side. All side lengths are not equal and there are no right angles, okay? So we can begin to kind of see things shake out here and thinking about, let's look at a square real quick because this particular quadrilateral has all the things. It has at least one pair of parallel sides. It has actually two pairs of parallel sides. It has two pairs of opposite sides, opposite side, opposite side. There's two pairs that are equal in length. Check. Does it have two pairs of equal length sides that are adjacent? If this square, if these two sides share this vertex right here, is defined right down here, adjacent sides, two sides that share a vertex, are they equal in length? Yes, they are. Are all sides equal in length? Yes, they are. Does it have four right angles? Yes, it does. Quadrilaterals, a square is a heavy lifter here. And let me go let's talk about a rhombus real quick. Okay, this is a special one too. Again, it has at least one pair of parallel sides. It has actually two. And the opposite sides, there are two pairs of opposite sides that are equal in length. And if we look at this vertex here, where these two sides meet, they share a vertex, they're adjacent to each other, they are equal in length as well. A rhombus has all equal sides. It does not have any right angles. So thinking about a square and a rhombus, they are very similar. The only thing that's different is a square has right angles. Okay, your students are going to have to be able to use a checklist or reason through the attributes to be able to classify these polygons. And the last one I want to talk about is new. For us, it is a kite. Okay, and a kite is defined as having two pairs of equal length sides that are adjacent to each other. Remember, we talked about adjacent being two sides that share a vertex. Here's a vertex, and these two sides are equal. We can clearly see there are two purple sides. And down here, we have another pair of adjacent sides that are equal in length. These adjacent sides share that vertex as well. So that is the one attribute that a kite has. Kite does not have all sides equal. There are no right angles. They do not have opposite sides that are parallel to each other, because if we place our Anglegs here, and if we continued these two lines on the same plane, they would eventually cross one another and intersect. Same with these two, okay? They would eventually cross, all right? This one wasn't done. Sorry about that. All right, but being able to see the attributes that apply that help us classify the quadrilaterals will be helpful for students to go back and answer this question. So thinking about our squares and our rectangles, what is true about all of them? They all have right angles. Well, yep, a right angle on squares, they do have all right angles. That's definitely true. They all have four sides of equal lengths. Well, we know that is not true, because if we go back to our rectangle, we can clearly see only two opposite sides are equal, okay? They are not equal. They all have opposite sides that are parallel. Yep, here's my square, here's my rectangle, parallel, that is true. And they all have four sides and four angles. C and D are both true. B is not true. So the answer choices would be A, C, and D. Okay. All right. So that was a lot with two-dimensional shapes. And let's go back and look at our three-dimensional figures that are included in this IOA. Again, our kids are required to analyze specific three-dimensional figures. Examples are rectangular prisms and a cube. They have to identify and describe the quadrilaterals as their faces of these figures, okay? So my question, or my problem here, is to identify and describe the faces of these three-dimensional figures, right? These are the three-dimensional figures we are going to deal with: a cube and a rectangular prism. They have to be able to identify the quadrilateral, the face as a quadrilateral. A cube has a square face. In fact, it has 6 square faces, top and bottom. All faces are squares, and there are 6 of them, okay? And then when we look at our rectangular prism, this is only one example of these, because a rectangular prism can either have all rectangular faces or squares and rectangular faces, okay? So let's take a look at this rectangular prism. We see one rectangle here, another rectangle, and another rectangle. So that makes 4 rectangles that are put together, and then the base of this rectangular prism is a square. So we have squares and rectangles that form this rectangular prism. And again, sometimes you will see the base, instead of having a square face, may have a rectangular face, okay? Ensuring your kids put their hands on these. These are the geosolids that are found in your kit. And then your kids will be asked to transition to this type of thinking here. Describe the three-dimensional shapes here. For example, looking at this particular prism, this prism has 2 rhombuses here and here as the bases, and the other faces around the shape are parallelograms, right? And if it is helpful, and we remember parallelogram, here's one of those faces. If we go back to what we know about a parallelogram, go back to our quadrilaterals. They have at least, there's one pair of parallel sides. They actually have two pairs of parallel sides, and the two sides are opposite sides are equal in length, okay? The rhombus here, okay, again, has at least one pair of parallel sides, but what's special about a rhombus, the opposite sides are equal in length, but in this case, a rhombus has all four sides that are equal, okay? So this prism, two rhombuses as the base and parallelograms as the other faces of the prism. This prism here has a face of a trapezoid, has at least one pair of parallel sides here. The other faces I see here are rectangles. This is a real skinny rectangle up here. And then the trapezoid again is back here in the back, okay? So being able to describe this prism as having two trapezoid bases and the other faces are different sized rectangles. And this prism here, again, this is similar to the one that we looked at here. It has a square face, okay, as well as over here or base, and then rectangles make up the other faces in this rectangular prism. All right, so your kids will have to use what they know about all quadrilaterals and polygons to gain access to IOA 6B. Classify, compare, and contrast polygons and quadrilaterals, and then identify and describe three-dimensional figures, all right? For more information, go check out our Analyzing the Standard document, and you will see more instructional strategies. Okay, let's take a look at IOA 6C that is in our geometry unit. This IOA requires our students to identify lines of symmetry in polygons. All right. So they are trying to find these lines of symmetry in all polygons, both three-sided, four-sided, five-sided, and six-sided figures. Here, we are going to anchor our thinking for this IOA in this particular problem that states identify the lines of symmetry in the following figures. You can see these are all quadrilaterals, and we will come back to this, okay? But for right now, I want us to jump into some of the concrete instructional strategies you will use when teaching this unit, right? I'm going to move that aside, and then I am going to bring in just a picture, an image of a trapezoid here. Folding shapes has a tremendous value for our students because it helps them clearly define if a shape has symmetry and if a shape can be folded on a line so that two halves match exactly, it has a line of symmetry, okay? Let's take a look at this trapezoid, right? I am going to fold this shape. I'm going to fold it horizontally to determine so that I'm folding it so the side lengths match up. And you can see they match. But what I do notice is that there is not an exact match. This part of the shape is not an exact match of this part, even though the shape has been folded into two parts. They do not match exactly. So horizontally, from this perspective, the trapezoid does not have a line of symmetry this way. Okay, well, let's consider if we fold the trapezoid vertically. If I take the trapezoid and fold it vertically and align the vertices to the vertices and the sides to the side, I can open it back up and clearly see that there was a line of symmetry. If I fold it back, I see that this half, the one that's on top, matches exactly to the half of the shape that's on the bottom. So what we have discovered is that a trapezoid has a line of symmetry this way when it's folded from vertically, when the trapezoid is oriented in this direction. Okay, let's take a look at the next shape we have. We have a rectangle. Well, let's consider what the lines of symmetry might be with this rectangle. Well, I'm going to try to fold this rectangle horizontal or vertically so that there's a vertical fold this way and see if when I fold it and I line the sides up, if this half matches exactly to this half. So I'm going to fold it, matching vertice to vertice, side to side, opposite sides to opposite sides. And what I see is that, you know what? Yep, when I folded this over, the top half matched exactly to the bottom half of this shape. So a rectangle has a line of symmetry that is vertical. Right there. The line that I've drawn where the fold is considered the line of reflection, like where it exactly matches up. Okay, well, let's check another way. Let's try to fold the rectangle horizontally. So I'm going to match the sides to the opposite side and the vertices together. And I fold them down and create that fold. And when I can clearly see before I even open this up, the top half of this fold in the rectangle matches the bottom half of the fold where the fold is in the rectangle. So this rectangle has another line of symmetry. So what we've discovered real quickly, sorry about my crooked line there, sorry, that a rectangle has two lines of symmetry, both vertically and horizontally. Let me see if I can make that better. There we go. It's a little bit better. And that a trapezoid only has one line of symmetry. I did want to mention before we get into using our Geo-Mirror with these shapes, I did want to go back and show you with our folding that your students should experience folding on the diagonal as well, trying to fold from vertice to vertice to determine if there is a line of symmetry this way. And if I crease my paper here on my rectangle, we can see that there's not a clean line of symmetry here, does not create an exact match on the other side. And we would also want to do that with our trapezoid as well, folding to the corner vertice, and then we can clearly see these are not exact matches. So there is not a diagonal line of symmetry here. Even if we were to fold from this corner to this corner, we were going to fold from here to here. Again, we can see based on the fold, there are not two exact halves that match. Okay, so we have discovered through paper folding, we have two lines of symmetry with our rectangle and one line of symmetry in our trapezoid. So paper folding is going to be one of your concrete instructional strategies you will engage in. And then I want to show you a tool that you'll be using with your students as well. You are going to use a tool that we call a Geo-Mirror. A Geo-Mirror is a reflective colored piece of plastic in the middle here that is used to reflect geometric objects, okay? To use the Geo-Mirror, you're going to stand it up so that the beveled edge, and you can kind of see here The beveled edge is right here. There's a dimension here that you can see. And also, let me flip it over. Also, you will notice here when you put your hands on yours, you will see that it is indented a little bit, but this is the side you want on the paper. Okay. So what I'm going to do, we are going to look at a trapezoid using a mirror, Geo-Mirror. We are going to look at a square using the Geo-Mirror. We are also going to look at the rectangle again through the Geo-Mirror. And then we are also going to look at a parallelogram through the Geo-Mirror. All right. So let's get started with that. Okay, so let's take a look at the trapezoid we explored when we were folding our shapes here. I am going to take my Geo-Mirror, and again, here's the beveled edge down here, and I am going to place it just below the trapezoid. I am going to determine, using my Geo-Mirror, if there is a horizontal line of symmetry. To do that, I'm going to just begin to slide my Geo-Mirror, and as you can see as I'm sliding it, I see the reflected image here appearing. And as I push it until it aligns with the opposite side length, I can clearly see in my Geo-Mirror that there is not a line of symmetry horizontally. Now, if I rotate my trapezoid here, I'll go this way so it looks like a trapezoid. It's a little distorted the way the camera is angled. I'm going to start again here with my beveled edge down, and I am going to slide my Geo-Mirror across my trapezoid, and I can begin to see the reflected image through my mirror. And as I continue to push my Geo-Mirror until it aligns with the vertices and the other side, I can see that there is a vertical from the perspective I'm looking at, or now horizontal with the way their shape has been rotated. There is a line of symmetry. And that line of symmetry, I can use my mirror, it will keep still and draw my line of symmetry there. And we discovered that when we folded our trapezoid as well from earlier. Okay. All right. So we've discovered a trapezoid has one line of symmetry. I'm going to slide that out of the way. And I want us to take a look at our rectangle. Here it is real quick. And again, the angle of the camera, in order for you to see the Geo-Mirror reflection, the shape appears a little distorted, but we're going to check this real quick. I'm going to start at the bottom of the shape and push my Geo-Mirror until it aligns with the other side. And I can clearly see that there is a line of reflection, or I'm sorry, a line of symmetry, which is the line of reflection right there, because they match, and I can clearly see it right there in my reflection in my mirror. Okay, so I'm going to rotate my shape and see if there's one this way. Starting here with my Geo-Mirror, I am going to slide it up. And as I do that, I think I'm just going to have to hold that. I can see that my image, it matches exactly. It's being reflected in my mirror here. So that means that the reflected image matches this image. Therefore, there is a line of symmetry this way in my rectangle. And again, we discovered that here as well when we folded our shapes. Okay. Let's start with the square and our Geo-Mirror. Again, I have my beveled edge that will be placed on the paper. I'm going to place it just under. I'm trying to position this just so you can see it with the camera. just below the shape of the square, and I am going to begin to slide my Geo-Mirror across the shape, starting at the bottom. And eventually, hopefully, you can begin to see the image reflected here in my Geo-Mirror. And as I continue to push my Geo-Mirror along, it does align with the two other vertices and the other side, which therefore creates a line of symmetry. So I am just going to try my best here to model. There's that line of symmetry. Okay. The other thing, let's go ahead and rotate it and see if there is a line of symmetry this way. And again, placing my Geo-Mirror at the bottom of my shape and gently sliding along until my reflected image in my Geo-Mirror aligns perfectly with the other side, creating two identical halves. There is another line of symmetry in this square. So far, a square has two lines of symmetry. Well, let's check the diagonal. We will start here and again slide the Geo-Mirror along. You can see the reflected image growing and getting bigger. And as I reach and there it is perfectly aligned. So there is a diagonal line of symmetry here. Okay, so there's one. So let's turn and check to see if there's a diagonal line of symmetry. Whoops, sorry. We're going to check. We want to place the Geo-Mirror from this vertice to this vertice. And if I had started here and followed along, we can see my image being reflected, and there's the identical half created through my Geo-Mirror on the other side. You can see it through here. And then I can draw, so that means there is another diagonal line of symmetry here. So a square has, well, my Geo-Mirror got it a little off. So there's one diagonal line of symmetry. Here's one vertically, two lines of symmetry. Then we have, and again, these would extend beyond, making sure our students understand that the lines extend beyond. Here's our third line of symmetry, and it would continue down this way. And then working our way around, here's our fourth line of symmetry. Okay, so a square has four lines of symmetry. All right, so let's check our parallelogram real quick. Again, I'm going to place my parallelogram here. I'm going to place my Geo-Mirror here, and I'm going to slide it along until I see an exact match for the other half. And as I continue to move my Geo-Mirror across my parallelogram, I can clearly see when I reach the side of the opposite side on the other side of my mirror, I can see the image reflected here is not an exact match. So there is no line of symmetry horizontally going across my parallelogram. What I want to do, let me go ahead and check my diagonal line of symmetry. I'm going to start here and slide my Geo-Mirror across. And as I reach the other side, the other vertice, I can again see here and here, there are not two halves that match exactly. So there is no diagonal line of symmetry. Well, I'm going to rotate it one more time so I can check it vertically. And as I progress along, I can see my image growing. But what I don't see as I continue and match my vertice up here in the top, there is no exact match. You can see the triangle that is created that's reflected in my Geo-Mirror. So what we've discovered, and because that's there's no line of symmetry here either. So a parallelogram has 0 lines of symmetry. Through our folding, we discovered a trapezoid has 1 line of symmetry. We discovered through folding a rectangle has 2 lines of symmetry, and we discovered through folding that through our Geo-Mirror, that a square has 4 lines of symmetry. Okay, so after exploration with paper folding and using a Geo-Mirror, our students will be able to gain access to the problem we had earlier. Identify the lines of symmetry in the following figures. So thinking about this, our students, I would expect them to be able to draw a diagonal line of symmetry there, another one here, and that also means if I fold it vertically, there is a line of symmetry creating 2 halves. And then, oops, I got off a little bit. I apologize about that. And there is a horizontal line of symmetry here. Sorry, I didn't hit that midpoint. Sorry about that. And then continuing on with our rectangle, there's a vertical line of symmetry and a horizontal line of symmetry. And our kids could also use the Geo-Mirror here as well. You can see the images there. And if I were to rotate my paper, sliding for my trapezoid, I can see my faint image here has aligned. So there is a line of symmetry there, and that certainly makes for a better, prettier line than what I did freehanded. And then again, with our parallelogram, our students can use the mirror to see the image reflected here does not match. I can place it vertex to vertex and see the image here does not match. And if I wanted to place it vertically, the image in that does not match either. Okay, so these are some of the items your students will engage in. As far as the abstract level, they will engage in when problems such as Coleman is thinking of a figure that has at least 2 lines of symmetry. Just looking at the shapes we have here, he could have drawn a rectangle because it does have 2 lines of symmetry, or a square. The trapezoid only has 1 line, and obviously the parallelogram does not. All quadrilaterals will be focused on in working with symmetry, and it is with all polygons as well. Okay, so they will be exposed to hexagons, pentagons, triangles to determine symmetry as well. For more information, you can go to our Analyzing the Standard document and find out some more.
So which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematical strategies for teaching and learning are not mandated by the Georgia Department of Education, nor will they be assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview.